Welcome back everybody, I'm Jolene Moon. You've landed on my Science is Magic YouTube page where I talk about the science and maths that fascinates me. This is the second week of filming this GCSE Minecraft and Chill series where I talk about what you're going to need to know in your GCSE exams and entertain myself by playing Minecraft at the same time, and possibly also you. And whatever you do, grab a cup of tea, relax, do whatever, possibly also absorb some revision advice at the same time. So if you caught up with me last week, you'll have seen me fight the Ender Dragon and bridge to my portal gateway and then reach this end city, which has a ship, and I stopped it there. And off camera, I went back and got some stuff, and we're going to come back and get all of the goodies inside this city today. While I talk about this week's videos have a theme as well, and that theme is mistakes, misunderstandings, and just general musings. So it's going to be very, very chatty again. They're not all going to have a theme like this. They're not all going to be themed or as chatty as this. I'm going to start getting into specifics of subjects next week. But for now, I'm just going to keep things extra chill. And if there's anything you want me to talk about, let me know in those comments. But I'm going to go ahead and start talking about mistakes that, so obviously as a tutor I have students making common mistakes all the time. That's not what I'm actually talking about today. Today I'm going to be talking about mistakes I used to make all the time, because I also used to make quite a lot of common mistakes, so maybe you will be able to laugh at me or learn something from me. I don't know, we'll see. And the first and biggest mistake I used to always make was not doing the same thing to the top and bottom of a fraction. And for that, you need to understand, and I think this is the issue, is that I didn't understand fractions properly. They represent a sort of, you're in a different counting system when you're considering fractions. Whatever the denominator is essentially what you're counting in, and you can't just do something to the top without repeating what you're doing to the bottom, otherwise you change the quantity, because counting 2 out of 7 is not the same as counting 2 out of 5 or 2 out of 10 or whatever it is. So you can't just, they're not just equivalent like that. For equivalent fractions, you need to transform the denominator and make sure the denominator relates to one another and do the same multiplication or division to the top that you do to the bottom. And that same thing applies to both sides of an equation. If you're trying to solve an equation and you're making mistakes, are you remembering to do the same thing to both sides of said equation? Because if you're not, that might indicate that you're forgetting what you're, the meaning of what you're doing to these equations. I'm going to be pelted up to land back down here. Just wondering where I should go next. Should I do? I think I'll save that one for last. I think I'll go this way actually. With an equation, you've got to remember that if you're changing, it's kind of like the horizontal sides of the equal sign are kind of like the top and bottom of a fraction. If you change one side without doing the exact same operation and quantity change to the other, you're changing the meaning of that equation. You're no longer counting to the same thing. They're no longer equal. So you completely change the meaning of the equation when you do that. And obviously that's not good. You don't want to do that. Wow, they are really, really going for me. What happened to my arrow there? And the second biggest mistake kind of follows along from this and is why this mistake kept happening for so long, because I was not writing down my working. If you don't write out your working, you're not going to know when you come back to your notes after months, after weeks of having learned what you were doing for the first time. If you're going back to practice and revise from your notes, you're not going to understand why you did something wrong or where you went wrong if you haven't written out your working. Equally, in the exams, as part of your exam strategy, if you haven't written out your working, they can't award you any marks for anything that you were doing. If you were not clear about the steps that you were taking and whether, you know, it's the difference between, are you trying to do something completely incorrectly, or have you just like misunderstood a decimal place, or, you know, noted something down ever so slightly wrong. And that can be the difference between getting 2 out of the 3 marks for a question or not, you know. And you want to get as many marks as possible in an exam, if you can help it. So bear that in mind. And I was terrible for just skipping right ahead and rushing and just getting to the answer and being like, oh, I know how to do it. I just skip right ahead and write down my answer because it's probably right. And if it's not, well, I wasn't ever going to get it right anyway. And you know, that's not the attitude to have. So write down your working. Take it from me. Got some diamonds there. That's pretty good. I'm gonna just the next mistake, and again, it kind of, all of these I guess I could have summarized by just saying the one thing. The next mistake that I used to make all the time was losing track of negatives. Now, I always tell my students, negatives are really hard, don't feel bad. They're so confusing, and if I didn't write down my working and I wasn't doing the same thing to both sides of an equation, it is incredibly easy to lose track of, well, that was a mess, wasn't it? Incredibly easy to lose track of the negatives because they can just get lost. You've got to remember to always make sure that you're following what the negative is doing. If it's outside a bracket, make sure you're multiplying the negative through everything that's inside the bracket. And if you're trying to get rid of a negative, like a -3 on both sides of an equation, you've got to make sure that you do add 3 to both sides of the equation instead of trying to subtract it. Now, okay, here we go. Very, very easy to lose track of them. They're very pesky negatives. And the next thing is not reading a question properly. So in the same way that I might like not write all my working out and assume I know the answer and know what I'm doing, I might not read a question properly in the first place, which obviously is not going to help. So for that, okay, that was not great. You want to make sure that you've really, really thoroughly read the question and know what you're doing, especially when the questions are really confusing or they can be asking you for something really similar. So for example, one of the things I used to be absolutely terrible for forgetting to read the question properly was in graph questions, where you have to either find a parallel or a perpendicular line. And I was utterly useless at checking that I had read that correctly. And I would often confuse which one I was supposed to be doing. And obviously you lose those questions, you get 4 or more marks for them. So you definitely don't want to be throwing those away by not reading the question properly. Similarly with speed, distance, and time graphs, or velocity, acceleration graphs, if you have those on your syllabus, making sure you know which one you're dealing with and what graph you're looking at, reading the axes properly, absolutely crucial. Do not throw away those marks, because again, that's a bit of a hefty amount of marks that you can get for those. So be very sensible with your marks there, unlike me with that jump. Oh my goodness. And the last thing is kind of a really easy fix, and it's that I guess I could have put this in the misunderstandings category, but it doesn't just apply to this topic. So one of the mistakes I made was not learning how to find, it's really simple, how to find highest common factors and lowest common multiples properly. I just got confused by it and was like, oh, I'm not going to bother learning that. And I just kind of accepted that those were marks I had thrown away. I don't know why, I just dismissed it. I was like, oh, that's hard, I'm not doing that. And that's not the only subject I did that to either. I did it to quite a few of them, for no good reason. Oh, nice, I'm breaking 3. I'll have that for sure. And protection 3, not too bad. Got some emeralds and some gold. Nice. Okay. Yeah, and like I said, that wasn't the only subject or topic I did that with. I also did it with histograms, which I'm going to talk about in a minute. Just dismiss things because I'm like, oh, I didn't understand that perfectly the first time, so I guess I'm never going to learn how to do that. Why? Why was that my attitude? I don't know. But a very, very silly mistake to make, to just dismiss an entire topic outright because I find it hard. You can always read up about it, learn about it, figure it out, and grab those marks in an exam. There's no need to dismiss any particular topic. I mean, if you've really tried and you've really studied it, you know, use your discretion, be sensible about, you know, when you're wasting time and not understanding something, when you could be revising other things if you've not been able to get help for it or something, absolutely. But if it's a case of you've just dismissed it outright and you haven't even tried to revise it yet, no, don't do that. Try and revise and study it first. Alright, so that's the major mistakes that I made. So on to my common misunderstandings, and that's kind of similar to mistakes. And the biggest one, and kind of leading on from that final mistake, another one of the topics that I just dismissed was converting fractions to decimals. And now I love teaching that because I use my number line division method, which if you don't have a calculator, if you're in the non-calculator paper and you've got to do a fraction to decimal conversion, I just find it so much easier than trying to do bus stop method division or trying to count up on the times tables. And number line division really is kind of a method for just getting you through the times tables quicker without having to consider every single possible option for the times table that it might be. But yeah, I was like, that's really hard, I'm not doing that, and kind of dismissed it before even really giving myself a chance to understand it, which is utterly silly. And like I mentioned a minute ago, same situation with histograms. I was like, nope, that's too hard, I'm not doing it. For why? I just did not understand the different axes of the graph. I didn't understand why they were being plotted that way. I could not get my head around frequency density and what that meant, and why that was a quantity that I was having to study. Of course, it makes sense to me now, that you're looking for sort of a simpler way to represent a lot of data to compare different quantities, different numbers of frequencies that you've measured. And the histograms are really quite simple, and I just did not get them. Similarly, another thing which is, well, actually I would not qualify this as simple. If you really understand percentages and how they multiply, then it is simple. But if you don't, like I did not, I could not wrap my head around compound interest, especially because anything to do with finance, I just immediately switch off. I could not care less about money and capitalism. It just makes my brain go dark and switch off. I'd rather think about literally anything else. Well, that was sort of handy, I suppose, to meet me over here in this corner. I'll start attacking them all. Now, where was I? Same thing with sequences. I actually love sequences now. I'm going to talk about the Fibonacci sequence in a minute. I think they're fascinating. I love how they occur in nature. You know, exponential spirals, all that kind of thing. Really, really fascinating, really beautiful. But when I was learning in GCSE sequences and series for the first time, so confused, utterly confused. Could not wrap my head around how you find the nth term. Made no sense to me. But now I love reading up about different kinds of sequences. And sort of similarly, probability in general just confused me. Um, I suppose when algebra is involved into a new topic and you haven't quite wrapped your head around algebra, like I said, I was making a lot of algebra mistakes with my writing down my working. Um, Probability was a whole different ball game of confusion, and I used to. Oh, I'm going to take some damage when I drop now. It's okay. Yeah. Where was I? Probability. Conflating conditional, independent, mutually exclusive, and dependent probabilities, because they are all quite specific and different. Now, I want to try and shoot me up to there. There it is. Lovely, grabbing all these shulker shells so I can build a ghast farm is what I'm trying to do. And tree diagrams. Oh my goodness, how confusing are tree diagrams. Again, now it's something I find quite interesting. I like seeing how different situations can, multiply through, and we can calculate different probabilities for these things. But at the time, wasn't having it. Arthropods, just what everybody wants. Sweeping edge is not bad. Efficiency shovel, I'm breaking. Oh, that's pretty good. Alright. No smithing templates in this city though, so far. And yeah, we're almost done here. Okay. Let's go up to this little extra section here. So talking about me confusing tree diagrams and getting things all sorts of incorrect, this was not the fault of my teacher at all, and on all the mistakes and misunderstandings I had, like I said, just dismissing something because I didn't like how hard I found it. I had an incredible maths teacher, and he somehow made maths like sequences and quadratics and algebra, and I would not have improved my algebra or my maths at all. So shout out Mr. HH, who encouraged me to write out my working, to do it properly, to not dismiss the things I found hard, and he got me curious about things like the Fibonacci sequence and the golden ratio. Speaking of which, am I the only one whose teacher in maths at school showed us this Disney maths movie that had Donald Duck in it, and he went into Mathemagic Land? Was that anybody else, or was that just us? Because that feels like some kind of fever dream. It was so trippy and weird, and I can't even remember what it was called now, but I absolutely loved it. I thought it was hysterically funny, how strange it was and bizarre, and like, why was my crazy maths teacher showing me this? Crazy in the best way. He used to make us laugh a lot. And what that did, what showing me that video where I think they talk about the golden ratio. I'm going to have to try and find it now. I'm going to have to try and find the name. Let me know if you have heard of this film. Comment and let me know what it is. I'll try giving it a Google in a minute. Did I finish in here? I think I did. Yeah, okay. Because I can't remember. All I remember is that it got me really interested in the Fibonacci sequence and in the golden ratio. And if you don't know, those two things are connected. So the Fibonacci sequence is where we start counting either from 0 or 1, and we just count up. And what we do is the next number in the sequence is added to the two numbers previous. So if you have, so we start 1 and then add that to 0, we get another 1. Add those together, we get 2, so it goes 1, 1, 2. Then we get 3 because 2 and 1 add together to make 3, and so on, and we keep going like that. So it goes 5, 8, and an incredible and beautiful thing happens when you plot them in rectangles of sides with the length of the numbers in the sequence, so 1, 1, 3, 5, 1, 1, 2, 3, 5. And when you plot them, you end up getting a spiral that looks like a logarithmic or an exponential spiral when you plot the arc of a circle inside these rectangles or squares, strictly squares. And when you plot them like that, they look like a nautilus shell. I'm sure you've seen it. Same thing with the golden ratio. The golden ratio has an even more perfect spiral. And what happens with the Fibonacci sequence is that as you get higher, higher, and higher in the Fibonacci sequence, it starts to approximate the golden ratio spiral. And the Wikipedia page, I think, for the Fibonacci sequence shows you a little diagram of how the two sequences are close together. They show you a little diagram of the spirals looking similar to one another. Now, because I jumped down, I've lost track of where I was. Yeah, I was up there. Okay, great. I'm going to cross to that ship. So the golden ratio is really special. I didn't even get to talk about why, because it is this so-called divine ratio because it appears in nature all the time, and it's where the ratio of a number to a smaller number is the same as the sum of those two numbers to that first larger number. Now, if that made absolutely no sense, you're not alone. We're looking for a ratio where if a number is A and it is to ratio to B, the ratio of A to B is the same as the ratio of A plus B to A. And that, not very groundbreaking as a concept, but it is stunning how often that ratio is approximated or appears in nature, and how when you do the same thing that I was talking about with the Fibonacci spiral, if you plot the golden ratio spiral, it looks exactly like nautilus shells, and lots of the spirals in nature are exponential or logarithmic spirals, but they seem to be forever tending towards this perfect golden ratio, and lots of architecture is based on it and everything. Now I'm going to try and get over to there. Oh, that was not high enough. Oh dear. Oh dear. That's also going to come down, isn't it? Okay, I'm going to use my elytra because I do already have one. I'm just not a fan of using it because my laptop can't handle the lag created. Right, let's pop all my loot, my spoils in here. Pop that on. Alright. Where am I trying to go? Go up there. Cool. Get down, please. Lovely. Okay. Right. Sorry, I had to concentrate doing that. We were talking about the golden ratio. Oh, I could talk about the golden ratio for hours. I'm not going to, though. We're going to move on. And my last point for today is my musings on grades. And if you're one of my students and you're watching this, you know I will talk about this over and over again. And what I find interesting is that as soon as you get into real life, grades don't matter. I know they matter a lot at school. They mattered certainly a lot to me when I was at school. But the reality is that they don't matter as much as we think they do. I got a B in maths on my first try at GCSE maths. On my second try, I got an A. The A star was just out of reach to me, so that's a 6 or a 7. I got up to an 8, couldn't get the top grade of a 9. And I got an A and an A star at A level as well. So I did maths and further maths because it was weirder maths, it was harder. I found it more interesting, more challenging, more novel, so I understood it better, learned it better, and got a better grade in it. Whereas my core maths A level, I could not get the top grade on. And I made those silly mistakes that I told you about in my final exam, on my A-level maths exam, I made silly mistakes in my working. I didn't check my working through properly, and I didn't remember to check equations on both sides and things like that. Yeah, so there we go. But it didn't impact me as much as you think it will. I still managed to go to a great university. I still managed to do a PhD in physics. And now I teach maths and I love it. And I didn't love it so much at school because I was more focused on grades than on anything else. So there you have it. I hope this helped. I hope you had a good time watching me lose my dragon head. There it is. Great. That was me conquering the End City and chatting at you about maths. Don't forget to check out today's physics and chemistry videos. Don't forget to be kind to yourself. All words are spells. Live your best magical life. And I will see you next week. Palalam.